Originally, Java had no preprocessor as in C or macroprocessor as in assembly language. When you looked at a line of Java code, you could tell exactly what it was doing. With the newer versions of Java, by including special preprocessing commands called generics, you are able to instruct the Java compiler to do some special invisible checking. The action of generics is sort of like casting that works at compile time. Here is the definition of a simple wrapper class not using generics. This class is able to contain one object. It can hold an object of any class. This is an example of putting a string object into the wrapper and returning it. The type of object is not specified by the declaration of the method in the class, so it is necessary to cast the return object. Without specifying the type of object being stored, the wrapper is capable to hold anything. You could make a more restrictive wrapper and limit its contents like this. This is the same as the previous example, except this time the wrapper is more particular about what it accepts and what it returns. The object passed to it and returned from it must be a string. In this example, not only will the wrapper prohibit all but one kind of object from being placed in it, but it's no longer necessary to cast the returned value. It's known ahead of time exactly what is to be returned. Something similar can be done with generics this way. This is the same thing again, but in this case, the Java compiler has done some hidden type checking. The wrapper class is defined with a less than and greater than sign surrounding the variable that is to become the type of the object. You can use any symbol you like to specify the class name variable, but commonly single letter uppercase symbols are used. Whatever symbol you choose will be used throughout the class. Whenever you need to create an object from the class, you include the name of the type you want between the less than and greater than signs. When you put objects in and take objects out, it's just as if you had edited the class names into the source, except there is no source that represents the rules that are applied when the code is generated. The casting of the types is present in the generated code, but none of that information shows up in the source. Here's a rough idea of how it works. There is nothing you can do with generics that you can't do with your text editor. One way to look at generics is that it checks on the correctness of casting in the compiler instead of waiting until runtime. Here's how it works. The class is compiled into a regular class file, except the generic annotations are present, so the macro can be expanded when you use it. Under normal circumstances, a class file has the same name as the class it contains, but in this case, any type parameters that you have defined as part of the class name are left off the file. That is sort of correct because no information about the actual type is included in the code itself. Remember, the actual type information doesn't come about until later when you use the new command to create an object from the class definition. Code is compiled that will work equally well with any type of object, just like in our first example. When an object is created from the class, it is created using exactly the same code as would be created if none of the generic information had been included. However, the generic type information from the instantiation is stored along with the newly created object. When the compiler generates the code for such things as method calls and variable accesses, it does the type checking then and there. This is very much like type checking that's done in casting, but the check for casting is done at runtime. Generic type checking is done at compile time. This is really the only advantage of generic type checking, the fact that it's done at compile time instead of later at runtime. However, and this is important so you can understand what you can do and can't do, once the code to access the class members is generated, the type information is discarded. The absence of this information has some important effects on object-oriented programming, as we will see in upcoming lessons. In the Java documentation, this discarding of information is referred to as type erasure. And if you decide you want to use generics, you need to be aware of the limitations that this causes. In the next lesson, I will explain the generic naming conventions and some things about how it works with constructors and methods.